I'm Dhanushyan from CEC department. Today we are going to see about DC shunt motors and its applications. Let's see what is a DC shunt motor and what are the components it consists. At first, there are two main components, stator and rotor. DC shunt motors. Then in stator, main frame pole, interpole, pole shoe and toe. As well as in rotor, armature winding, armature rotor core, shaft and commutator. A DC shunt motor, also known as shunt-wound DC motor, is a type of self-excited DC motor where the field windings are shunted to or connected in parallel to the armature windings of the motor. Since they are connected in parallel, the armature and field windings are exposed to the same supply voltage, though there are separate branches for the flow of armature current and field current in electrical terminology. A parallel circuit is often referred to as a shunt. Hence, DC motors in which the armature and field windings are connected in parallel are referred to as DC shunt motors. Let's see what are the uses of DC shunt motors. Because of their self-regulating speed capabilities, DC shunt motors are ideal for applications where precise speed control is required. Keep in mind, however, that they cannot produce high starting torque, so the load at startup must be small. Applications that meet this criteria and are suitable for DC shunt motors include machine tools such as lathe and grinders and industrial equipment such as fans and compressors. Okay, let's see how DC shunt motors achieve such speed regulations. When voltage is applied to a DC shunt motor, the armature draws current sufficient to produce a strong magnetic field, which interacts with the magnetic field produced by the shunt windings, causing the armature to rotate. The rotating armature produces a back EMF which opposes the armature voltage and reduces the armature current. If the load on the motor is increased, the armature rotation slows and back EMF is reduced. Since back EMF is proportional to speed, the speed increases. Okay, let's see this theoretically. Look at the following equation. EB equal to pi PZ done by 60, where EB equal to back EMF, pi equal to flux, P equal to number of poles, Z equal to number of coils, and N equal to rotational speed. With less back EMF voltage and a constant supply voltage E, the net voltage increases. Then E net equal to E minus EB. The increase in net voltage results in an increase in armature current. Since torque is proportional to armature current, torque is also increased. Let's see the final equation for torque. T is equal to pi PIAZ divided by 2 pi A, where T equal to torque and A equal to area. Finally, this increased torque allows the motor to increase its speed and compensate for the slowdown due to loading. Hence, a DC shunt motor is able to self-regulate its speed and can be referred to as a constant speed motor. Thank you.